Math 76, Lesson 43, Simplifying Decimal Numbers and Comparing Decimal Numbers. So let's go ahead and do a problem so we can explain what we mean by simplifying decimal numbers. So let's say we have to multiply the following decimal numbers. Let's say we have to multiply 25 hundredths times 4 hundredths. Okay, so 4 times 5 will give me 20. I carry the 2. 4 times 2 gives me 8, plus 2 gives me 10, carry the 1, 4 times 0 is 0, plus 1 is 1. And then I put my placeholder, oh wait, zeros all around. So that's just going to be 0 for this one, 0 for this one, add up the zeros, and then we end up with 100. But then, remember, we have to count our decimal places. So let's go ahead and count our decimal places. I've got 1, 2 up top, 1, 2 on the bottom for a grand total of 4 decimal places. So now I go to my answer of 100, and I count over 1, 2, 3, 4 decimal places, put my decimal point, add a placeholder 0 there. So now I have the decimal number 0.0100. Now what I mean by simplifying decimal numbers is when we get an answer like this and we've got extra zeros at the end, this decimal number would be read as 110 thousandths, because this is the 10 thousandths place and this is 110 thousandths. The way we simplify them is we just get rid of any zeros on the end. They're unnecessary. So then we can just read this as 1/100ths. Now, the reason why this works is because if you remember, the first number I said would have been 110 thousandths, and the second number that we simplified would just be 1/100ths. Well, if we were to divide each of these numbers by 100, or reduce the fraction here, if we divide 100 by 100, we would get 1, whoops, not 10, we would get 1. And if we divide 10,000 by 100, we get 100. So this is just another form of reducing when we simplify our decimal numbers by not adding these zeros on the end. Some of you may have already known to do this, but maybe you didn't know why. The reason why is because of the way that decimals relate to fractions. If we were to write this decimal number as a fraction, it could be reduced to 1/100th. So the simplest way to write this is 1/100ths, or 0.01, as opposed to 110 thousandths. Okay, so that's how we simplify decimal numbers. Now let's talk about comparing decimal numbers. So let's go ahead and put a whole list of decimal numbers to compare here. Let's take 0.2 and we'll compare that one with 0.15, or 15 hundredths. So the question here is, which number is bigger, 2/10ths or 15 hundredths? Okay. One way we could do this is we could inflate them to the same place value, to inflate them to the same place value. So since 15 hundredths goes to the hundredths place, I could take 2/10ths and write it as 0.20, add a placeholder 0. Then the question is really simple. What's bigger, 20 or 15? The answer is going to be 20. The other way that we could look at it is we could look at the place value farthest to the left, because that's the one that matters here. All right, this 2 is definitely bigger than 1. So that's one way that we can do it. We can compare either the place value farthest to the left, or we can inflate the place value of the smaller decimal number and figure out which one is actually greater in value. Okay, so let's go ahead and do this on a couple more examples. Let's take 12 and 5/10ths, and we'll compare that to 1 and 25 hundredths. All right, so in this case, I've got 12 and 5/10ths and then 1 and 25 hundredths. So if I inflate this to the hundredths place, I then have 12 and 50 hundredths. And then I can see when they're both written in 4 decimal places, this one is obviously, when they're both written to 2 decimal places, this one's obviously bigger because we have 12 holes and 12 whole numbers to the 1 whole number. Or the other way is you could look at the whole numbers, again using the value farthest to the left, in this case being the whole numbers. We see that 12 is obviously greater than 1. So 12.5 is greater than 1.25. Let's see if I can find another curveball for you. Yeah, we'll do 2 more. Let's start with this one. We've got 0.4 being compared to 0.40. So on this one, let's say we use the method of the farthest decimal number to the left, or the farthest whole number. So the whole numbers are the same, both have 0. The decimal numbers are both 4. So we see the 4s are equal, so now the question is, well, which one's bigger? Well, from there we would then compare the second decimal number. So this one is just 0.40, and if this one has no extra number, so those are actually equal. We also see the same thing if we use the inflation method. If you take 0.4 and we add that placeholder 0, we see that they're the same number. All right. Now let's talk about one more. What if we have something similar to this? We have 0.4 being compared to 0.45. Which one is bigger? Well, if we use the inflation method, it's really easy to see. This inflates to 0.40. We see that 40 is less than 45. Or if we use the value to the left, we see 4 is equal to 4. However, this one has 5 extra. This one would have nothing extra. So this one would still be greater. All right, that's it for this lesson. If you have any questions, let me know on the school website, and I will see you in class.